Hello, Year 10. So today we're going to look at something called rationalising the denominator. Now, rationalising the denominator is not that difficult, but students often struggle with it because they forget what it means. So let's just go over what these two words here mean. So we know what the denominator is. The denominator is like the bottom number of the fraction. Just write that, bottom number of fraction. And this word rationalise simply means make rational. And I'm going to expand upon what that means. Make rational. So rational numbers are numbers like 1, 2, 3, 4, 5, 6. They are also numbers like 1.5 or 1.25 or a quarter. They are numbers that can be expressed as a fraction. So like 1/3 is rational. 7/1 is rational. Numbers like that are rational. Even recurring decimals are rational numbers because they can be written as fractions. Pi, for example, is an irrational number because it just goes on forever. It can't be written as an exact fraction. Now, surds are irrational. So when we are asked to rationalise the denominator of a fraction with a surd, what we are trying to do is stop the denominator being a surd. That is what we are being asked to do when you get a question where you're asked to rationalise the denominator. That's it. So for example, you could get given this. You could get given rationalise the denominator of 3 over root 5. So here we've got a fraction. The denominator is a surd. We want to rationalise the denominator. And the way you do that is you simply multiply by the surd that's on the denominator. So I'm going to multiply by root 5. But I'm actually going to multiply by root 5 over root 5. And the reason I can do that is root 5 over root 5. You could try this in a calculator now. Root 5 over root 5 is just the number 1. So all I am doing is multiplying by 1. But watch what happens when I multiply. 3 times root 5 is 3 root 5. Root 5 times root 5 is 5. And so by doing that, we have stopped the denominator from being a surd. And so this here is your final answer. I was meant to highlight that more nicely than I did. Right. Let's try a second one. I'll just try and make it a little bit clearer. So let's say we had 3 over root 6 times, ignore that. Imagine we had 3 over root 6 and you're being asked to rationalise the denominator of 3 over root 6. So to rationalise the denominator here, so to stop this root 6 being a surd, we need to multiply by root 6 over root 6. And when I do that, well, 3 times root 6 is 3 root 6. Root 6 times root 6 is just 6. And so we get this, 3 root 6 over 6. This time though, this isn't our final answer, just because this is a fraction now that can be simplified. And the reason this fraction can be simplified is ignore the surd bit, just look at the 3 over 6. 3 over 6 simplifies to 1 over 2. So we are left with 1 root 6 over 2. And then remember, we don't normally write ones when we're doing a manipulation with surds. So finally, I would expect it to just be written as root 6 over 2. And that's it. Okay. I'll show you a slightly harder one now. Let us try. So here we've got 3 over 2 root 12 and we want to rationalise the denominator. So to rationalise the denominator here, you only need to multiply by kind of the surdy bit. So I can just multiply by root 12 over root 12, like that. Now when I do that, on the numerator of my fraction, I'll have 3 root 12. Now on the denominator of my fraction, we need to be super, super careful here. I will have this 2, and then I'll also have root 12 times root 12. Now root 12 times root 12 is just 12. So that's what I've got so far. And now we've got a bit of simplifying to do. So the first thing you need to try and spot is this root 12 up here on our numerator can be simplified. To simplify a surd, we are looking for a factor that is also a squared number. So your squared numbers 1, 4, 9, 16, 25 and so on. We need to find a factor of 12 that is also a squared number. That number is 4. So what this means is I can rewrite this 12 as root 4 times root 3. All I've done there is rewrite my numerator. I'm going to rewrite the denominator as 24 because 2 times 12 is 24. Onto a new line. So on my numerator now, I'm going to do this in one step. We've got 3 times root 4. Now root 4 is the number 2, so it's 3 times 2, which is 6. So I've got 6 root 3 over 24. Almost there, year 10. There's just kind of another bit to simplify and make it perfect. With this, ignore the root 3 for a moment. Just look at the 6 over 24 bit. 6 over 24 is the same as 3 over 12, and then it's the same as 1 over 4. So we can divide by 2, divide by 3. Okay, so because of that, we end up with 1 root 3 over 4. Which then can just be written as root 3 over 4, like so. Okay. So all you're trying to do, all you need to remember for each of these examples, you just multiply numerator and denominator by the surdy bit that's currently in the denominator. If you do that, you should be absolutely fine. Have a go with this, and as ever, let me know if you need a hand.